This is the solutions for the review test. Um, the first problem is a little bit different than the problems we've done, but the approach is the same. Don't get scared by the fact that it is not an exponential function plus a constant. Don't be afraid of the fact that it is an exponential function that's over space instead of time. Normally, our exponential functions are showing that some quantity is growing or reducing over a period of time. This is just saying that the chain is going down and up according to an exponential function. It's the same thing, the same approach. You put it in your calculator, you plot points. That's it. Okay. So it says that we have a chain hanging between 2 points. It kind of hangs in a arc like this. The lowest point is P. It hangs between x equals -2 and x equals 2. It's like a little graph here. And they give us a equation which tells us how the chain hangs, okay, which is y equals 2x plus 2 to the minus x. So you just put in the x coordinate in this equation and it tells you the height of the chain. And of course, this equation is valid between -2 and 2 because that's where the chain is, right? It doesn't make sense to be outside of that range. So first it says calculate the height of the point P. The point P, you can see, is at x equals 0. So all we need to do is figure out what this equals at 0. And there's two ways of doing that. We could use the calculator or we can use just our knowledge of exponents. So let's just first try to do it by hand. So we'll say, okay, the shape of the chain is y equals 2 to the x plus 2 to the minus x. And we know that we want to find out what y equals at 0. If we find out what y equals at 0, then we're going to find the height at point P. So we can see that x equals 0. We can just substitute in here. We'll substitute in 0 for both of these. And then you'll remember the famous words of Donino, that 2 to the 0 is 1. So we have y equals 1 plus 1, which is just 2. So we've already found out that the height here is 2, and we haven't even used the calculator yet. But you could have used the calculator to do that, and you could use the calculator to find out a bunch of points. So why don't we do that just so that you can see how to do it with the calculator. We turn the calculator on, and we go to the y equals screen, and then we are going to put in 2 to the x plus 2 to the negative x. So that's our function. Let's see what it looks like. Okay, so it looks kind of like this one here, except you just cut it off at -2 to 2. Okay, and of course we want to look at it in the table too. And so we can see that at x equals 0, it is indeed y equals 2, which we calculated in A. Find the range of y. Well, so basically the range of y would be between this point and this point, right? So y ranges between, let's see, the lowest point would be 2, or yeah, 2. Okay, and then the highest point would be right here. We can just look on the calculator for that, or we could use our brains. But let's see, at -2 it's 4.25, at +2 it's 4.25, so it's 4.25. So we already know that the range for y here is between 2 and 4.25. And you might say, wait a second, but this goes up forever. But remember that the domain is specified to be -2 to 2. So we cut it off here, and that means it does not go up forever. It stops right there. Okay. So how can we figure this out without the calculator? Well, you just take the equation, which is y equals 2 to the x plus 2 to the minus x, and we're going to substitute, instead of 0 this time, we're going to substitute, for example, 2. And if we substitute x equals 2, then we have 2 squared plus 2 to the negative 2. And 2 squared, of course, is 2 times 2, which is 4. 2 to the negative 2 would be 1 over 2 squared, because remember the negative kind of inverts everything. And then it just puts the exponent without the negative in the bottom. Well, 1 over 2 squared is 1/4, so it's 4 plus 1/4. 4 plus 1/4 is 4.25. Hey, what do you know, 4.25? And one thing you might also see here is if you put in negative 2, which is this point here, you are going to get 2 to the negative 2 plus 2 to the negative 2, which is 2 squared. And what do you know? You get the same thing because you're going to have 1/4 plus 4. You're also going to have 4.25, which makes sense, right? At negative 2, the height is 4.25. At positive 2, the height is 4.25. Okay? But anyway, the range is going to be between 2 and 4.25. Okay. Now for number 2. The population of fleas on a dog after 2 days is modeled by this equation. Okay, so since we have an equation, of course the first thing we want to do is we want to put it in the calculator. If you have an equation, why not? You should always put it in the calculator. Even if it doesn't ask you to graph it, you'd be crazy not to. Okay, and then you put x or t divided by 4. And we're pretty used to putting our exponential functions into the calculator. I think everybody's doing pretty good with doing that, even if they don't ask you to graph. I don't think we're so good with parabolas and other kinds of graphs. You guys should be more aggressive about putting things in your calculator. Okay, so there's our graph. But usually the table is more helpful than the graph, right? And what do you know? Look at this. They're just asking us for n values or y values for our t values or our x values. So, like for example, 0 maps to y equals 4. Hey, look, they don't know that it's y equals 4, but we know because we did it in the calculator, so we know that this is 4. Okay? Let's see if the other numbers correspond. They say at x equals 4, I can just rename t and n here to x and y because on the calculator we use x and y. So x equals 4 is y equals 8. Let's see, is that, yeah, that's true. X equals 4 is y equals 8. So let's try to go down a little bit more. Let's see, 8 comma 16, yeah, that's true too. 12 comma 32, yeah, that's true too. What about 16? I bet it's going to be 64. There it is, 16 comma 64. Okay, we already got that answer. 20 comma 128. Okay, so we got all the points just by putting that in. How easy can you get, right? Write down the value of p and q. Well, p is 4, q is 64, and all we just got that by putting this function into the calculator. Okay. Using the values in the table above, draw the graph of n for 0 to 20t. Use 1 centimeter to represent 2 days on the horizontal axis and 1 centimeter to represent 10 fleas on the vertical axis. Okay, so let's see. We're on the y-axis. We are going to range from about 0 to 128. On the x-axis, we're going to range from about 0 to 20. Okay. So on the x-axis, we're going to go from 0 to 20, and we're going to have 2 days for every centimeter. Okay, so let's go down to the graph paper. And so we're going to have 0 to 20, counting by 2's for the x-axis. So, and you should use a ruler on the test. Okay, 0, 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. Okay, and this was, I forgot what that was. I know that the y-axis is fleas, that's hard to forget. And the fleas, we're going to count by how many fleas? 10 fleas per centimeter. Each one of these squares is about a centimeter. 10 fleas, 20 fleas, 30 fleas, 40 fleas, 50, 60, 70, 80, 90, 100, 120, oops, 110, 120, 130, 140, 150, 160. I already went past. I only need to go up to 128, right? I think. So I need to go up to 130 maybe, right? Because 128 is the biggest value. And then, so this is fleas. I'm going to label it fleas. And the x-axis is 2 days. It's days, 0 to 20 days. Oh yeah, it was how many fleas on a dog from 0 to 20 days. Okay, and then we're just going to graph some of our numbers. For example, let's see, 0, 4, 4, 8. 0, 4, 4, 8. 0, 4, 4, 8. I think it's like, it was 8, 16. Oops. 8, 16. 12, 32. 16, 64. And 20, 128. Okay, I'm just going to use a different color here to connect the dots. Now this, of course, you're not going to be able to use a ruler to do the curve. You just need to use your pencil. So it looks about like that. So we did this, okay, and we used the increments they asked us to. 10 fleas, 2 days. Okay, last thing. Use your graph to estimate the number of days for the population of fleas to reach 55. How would we do that? Well, fleas 55 would be right there. And what number of days does that correspond to? About 15. See, they're right between 14 and 15. So I would say it's about 15 days according to the graph. So I would say 15 days. Of course, on an IB exam, you would want to put all your answers here. Okay. Now we could check that with the calculator, right? It said to use the graph, but let's use the calculator to see what that would be. So we found it to be, oops, I'm going way too high. 15 days, not 50 days. Okay, so I'm looking basically for 55 fleas in the Y column. Went way too far. It's between 15 and 16, right? 53, that's pretty close. It's about 15, pretty close to 15, maybe a little bit above. But like the graph gave us 15. I think that's a good guess. Okay? And then, so here's the graph again. Okay? And then we have one more problem, which I will do in a separate video.